Now going on with continuous charge distribution. Okay, think about that. A charge distribution. What does that sound like to you? You might think various things. I don't know, different ideas. I know I definitely had a variety of ideas when I first thought of this, or when I first learned about it. And I thought, I don't know, you distribute it evenly among all charges, make all charges equal. But what this basically means is a collection of charges, okay? Let's put it that way. Now, let's say that you have two charges. I don't know, let's say a +5, okay? And you have a -8, okay? Those are the two charges that you have. All right, these two right here. Let's put them smack dab in the center. Okay. All right, so this is what we would be able to call a discrete collection of charges. Okay, why is that? Because we are able to count the individual charges and know that they're the only ones that we are working with. So here, in this tiny space, we know that we only have a +5 and a -8, okay? So right over here in this space, we can actually count. Here is 1 +5, here is 1 -8, okay? And once again, this is what we call a discrete collection of charges. Okay? And we also know that there is nothing in between. Okay? And once again, we can physically, legitimately count that there is one charge here, one charge here. Okay? And that is what a discrete collection of charges is. But now let's talk about what's drawn here down below. This is the other type of continuous charge distribution, which is basically and precisely the topic of today. Okay? So now let's say that we have a wire, and this is negatively charged or positively charged. Let's go with positively charged, okay? Now, with contrast to the discrete collection, there are positive charges all throughout the wire and not in two separate places. And while now these can be more crowded to a certain side, or they can be evenly distributed, as we can see here. But they have the same coulombs, and the wire is negatively charged everywhere. Okay? Now, what I'm referring to is called charge density. And we can get into that in another video, but basically what charge density means is what I previously mentioned. So for example, here we can see that all the positive charges are evenly distributed. Now, what would happen if, for example, we have something like this? Now, what this would mean is that there is more of a charge crowded towards this area over here, okay, than there is here. Now, this doesn't mean that there isn't any charge here. This is just a representation of where the crowd is heading. But the entire wire is still positively charged, okay? What charge density means is which side of the cable, in this case, is more positively charged than the other. Now, this can work with negative charges as well. This is just an example, okay? And that's basically it for continuous charge distribution, okay? It's a very, very simple topic, and one in which there is not that much of an explanation per se. It's more of a concept that once you understand it, it's pretty easy to be able to remember. And yeah, that's pretty much it, okay? Continuous charge distribution, once again, I'm gonna go ahead and erase this discrete collection of charges because that's kind of another topic that we're not really working with today. So a continuous charge distribution is, once again, we have a wire just around here, okay? And these are, well, they can be either evenly distributed, as we can see here. Okay, I'm gonna put this in another color. As we can see here, okay? Or I'm gonna go ahead and put the crowd again. Okay, or they can be crowded, okay, as we can see here in the bottom section. Okay, so once again, I just don't want you to forget, in these spaces right over here, over here, over here, these are spaces that they do have the positive charge, okay? It just means that they're more crowded towards this area. But the entire wire is continuously charged, okay? In this case, with a positive charge. Okay, perfect. Thank you, guys. That's it for this topic.